In Algebra 2, section 7.8, we're dealing with using exponential and logarithmic functions. So you're introduced to an equation for exponential growth and exponential decay using base E. Now, you have been introduced to these kind of exponential growth and exponential decay before, but those equations are specifically related to finances. Well, this has to do more when we're dealing with science and half-lives and gases and whatnot. So there is a letter in here, K, which basically K represents the rate of continuous decay or continuous growth. Okay? So the first thing we're going to do is we're going to find the half-life of sodium is 2.6 years. Now, so we know that this is our T, right? And if we're dealing with half-life, we're doing 1/2 of a complete rate, which is 1/2 of A. This then is will be our Y, which is also our f of x. So it looks like this. 1/2 is 0.5 of A equals A of e to the k. We don't know our k, but we know our t is 2.6. This equation then will help us find the rate. Once we find the rate, then we can plug the rate in, and we're able to solve for A. Once we find A, then we can find the equation. So we have to break this down. It wants us to find the value of k first, because without the value of k, I can't write the equation. And once I'm able to find k, then I can plug that in, and then I will find my equation. So one thing at a time. First, I'm going to find the value of k. I can do this. Again, I put 0.5a because we're not dealing with a full life, we're dealing with half a life. So this exponential decay, because we're dealing with decay here, so it should be a negative k. Okay, so I'm going to start off with dividing both sides by a, because again, I can't solve if there's too many variables, and I have variable a and variable k. So in this case, this cancels out and this cancels out. This gives me 0.5 equals e to the negative k 2.6, right? And the opposite of base e is natural log, and then natural log. This cancels out, leaving me with negative k 2.6, and we need to find the natural log of 0.5. Is negative 0.6931. Okay? And so now I can divide by negative 2.6. The negatives cancel out, and then points divided by 2.6. This will give me 0.2666. And this cancels out in the negative, equals k. So this is then, once I have k, this is my value of k, and then just 0.2666, I plug it in again to the original decay equation. Now, when the equation, I used the t that they gave me in order to find k. But once I find k, the only thing I need to fill in is k, because I need to know the rate of continuous decay or continuous growth. So the equation is y equals a e to the negative, because I'm doing decay, 2666 t. Because now I can put any time or any a, which is my initial value, that's what a means, and then I should be able to find one or the other. So go ahead and pause and write this down. We have one more equation for you, so make sure that this is written on your paper. So number 2 states, a geologist examining a meteorite estimates it contains only 10% as much sodium-22 as it would have contained when it reached Earth's surface. How long did the meteorite reach the surface of the Earth? Well, I do know that sodium-22, its constant rate of decay is found in from the last section, the last question. K equals 0.2666, negative, yeah. The thing is that now, instead of, because this one I used half-life, so that's 0.5A. But in this case, we're using 10% as much as a full life. So instead of 0.5, we're doing 10%, so 0.1 of A equals, we're still doing decay, AE, because we're moving backwards to find how long it's been on the Earth, E minus 0.2666, and then I'm looking for T. I'm trying to figure out how much time that it took to get to for 10%. So the same thing, I'm going to divide both sides by A. I end up with 0.1 equals E negative 0.2666T. And then so I'm going to natural log. This cancels out, giving me the natural log of 0.1. Is negative 0.3026. No. What am I thinking? Negative 2.3026 equals negative 0.2666T. So I'm going to divide by 0.2666, negative 0.266. I should get a positive 8.64. So about, we round up, 9 years. Go ahead and write this down. And again, these exponential decay and exponential growth equations deal specifically with scientific as opposed to your other one, we dealt with financial. Pause this and write this down. Try page 513, number 1, and I will see you in class.